All right, hey everyone, how's it going? We're just gonna finish a look at part 2 of our 2D problem lesson. We'll do a couple of word problems, and then you'll get some times to try the practice questions on your own. So here, we're just gonna go over two quick examples of some directional angles because they come into play in some of the word problems. So again, I want to sketch the direction angle of something that is south 75 degrees east. So for these ones, right, we want to write or draw ourselves our compass rose. So north is up, south is down, east and west, okay? So here, right, so which way is south? Well, so south is this way, right? So we know south is this way. Now, which direction is going to be 75 degrees east? Well, east is this way. So like I'm traveling roughly here, and this angle is 75 degrees, all right? So again, south, 75 degrees east. Again, this is 90-degree triangle, or sorry, 90-degree angle. So that means if this is 75, then this angle here is going to be 15 degrees, okay? So let's try another one down here. So again, I'm going to draw my compass rose. Never eat shredded wheat. All right. And then same deal. We say, okay, well, I start with north, right? So where is north? North is this way. Okay. 32 degrees east. Which way is east? East is this direction. So this chunk here is 32 degrees. All right. And again, we know this whole thing is a 90-degree triangle. So this angle is just going to be 90 minus 32. Okay. So what we'll do is we'll try a couple of questions where I have these kind of directional issues and how I draw my diagram. Okay. So let's do this example, and we'll kind of draw it out as we talk through it. Okay, so a small plane takes off at point A. Okay, so call that A. On a calm day with no wind and flies directly east. Okay, so directly east is going to be completely horizontal this way to some point B. Okay, I'll fill in the numbers after. It says then it turns so it then turns so that it's heading 20 degrees west of south. So now again here what I can do is I can kind of use my like what we were doing previously, right? So I can say, okay, so where am I? So if right, this is my directions. Here we are heading 20 degrees west of south, right? West of south. Well, where is south? South is this way, right? And then which way is west? If I go straight, it's going to be in this direction, okay? So this chunk here, okay, is 20 degrees west of south. All right. And then from there, I go to some point P. Or sorry, not P, C. Right? So now here I have my triangle. So let's fill in the numbers that I know. So from A to B is 75 kilometers. From B to C is 55 kilometers. So now I have my picture. Now you may be thinking, well, I have no numbers in my triangle. But again, so like this whole thing is 90 degrees, right? If I pick another color, right? This whole thing is 90. So that means that this angle measure, if this is 20, this has to be 70, okay? So now if you notice, even before we get to the actual question, if I just make this highlighted, what am I given? I'm given a side, I'm given the angle between it, and another side. Okay, so when you look at that, you should be thinking, I'm going to use cosine law to solve this. Or at least I'll be asked a question about the cosine law. So yeah, so when I get to part A, it says determine the distance from point C back to point A. So here, we want to figure out this, which is side B, because that's angle B. All right? So for part A, we will use the cosine law to solve for side B. All right? So if I plug in what we know, so right, it's going to be b squared equals a squared plus c squared minus 2ac cos of angle b. B squared equals, so I'm going to have, so 55 squared plus 75 squared minus 2 times 55 times 75 times cos of 70. And this you can literally punch in to your calculator, like as you see it. I'm assuming most of you are using a scientific calculator that has been made in the past 5 years. So I will just take a second to calculate this, and you can do the same. I'm still here if you're wondering. I'm just using my iPhone calculator, which I kind of don't like. So I got, where am I? So I get b squared equals, so this whole thing, when you punch it in, you should get 5,828.3. And then I square root that. So the distance between point C and point A is roughly 76.3 kilometers. Okay. So again, if you had an error with getting 5,828, you may just have to try your calculator again, and you may have punched in the wrong number. I don't know. Okay. And if you're having calculator issues, then just, you can ask, send me an email or something if there's really like a super, super huge problem with you not getting the correct answers. Okay. So now for part B, we want to figure out what should its heading be at point C to be able to fly in a straight line back to A. So if I look back at the picture, right? So here, like, now what heading? Heading we want to talk about in this kind of sense here, right? So like, if this is my right angle, right? My compass rose, I want to be able to give some sort of a direction, okay? So that means what I got to do is I have to figure out what angle C is to help me figure out what the bearing is going to be, okay? So for part B, we are going to use the sine law to find angle C, all right? So we have sine of C over little c equals, and now let's just scroll up. So what do I know? Well, I just found side B and I know angle B. So that's the ratio, the other ratio I'm going to use to complete this one. So sine B over little b. Okay. And then now I'm going to plug in everything we know. So so C is unknown. Or sorry, angle C is unknown. I know what is side C, 75. So that's going to be 75. And then sine of 70 over B, and B we just got from part A, which is 76.3. Okay, so now I got to solve for angle C, which means here I'm going to cross multiply. So I'm going to have 75 times sine of 70 all over 76.3. So now again, this thing on the right hand side, you can use a calculator. So I will do so quietly as I sit in my son's room. It's the only room that I can get some quiet. So all right, so I got, so sine of angle C, I got 0.923682130523501. And then to get angle C, I do sine inverse of this whole thing. And we will get an angle of approximately 67. Oops, okay. So now what we'll do, let's go up to our picture. So I know this whole thing here, 1 second, let me add some color to this, okay? So like this angle here, we just found out to be is 67, okay? But what I want is I want to say a direction, okay? So here what we're going to do is we're going to look at, well, so like if you remember from your previous math classes, right? Like I have a Z pattern right there, right? So then I know, so that, oops, let me just undo that. So like this angle down here is 70, right? So then, actually it looks confusing. Let me just move this over here for now. Okay, so this angle is 70. So then now that means that like this angle in here, okay, this little one is 20, right? So then if that is 20, then what's this chunk? Well, this chunk right here is going to be 67 minus 20. And then what's that? Well, that's 70, and then that's 4. So like, so this chunk here is 47. So let me just go down here for a second. So literally, so what we have, right? So that's 70, that's 20, and this is 47. Because remember, this whole thing here was 67 degrees. And then now, in terms of a direction, right? Like what are the, well, if I look, what should be its heading? So heading is, right, is literally what is the direction, the official direction, okay? So for this, what can I say? Well, if this is north, this is going to be, sorry, right, north, and then how many degrees west? 47. So I could say north, 47 degrees west. So if from this point, right, because this is point C, I want to get to A, right? What bearing should you travel? North, 47 degrees west. All right? So that would be the answer for that one. Okay? Hopefully that one isn't too bad. I know generally humans, we're not very good with directions, and with the fact that we can use Google Maps all the time, we don't ever really think about where we're going. We just look at our screens and trust that it's correct. But yeah, like all that compass stuff sometimes can be a little triggering or annoying. Anyways, last example, diagram below depicts all this information. So all this stuff here is on the picture down below. Okay. So, right, I have this length is 1.95 meters. This is 1.95 meters. This is 45. This is 45, 2.4, 2.4. So literally this triangle, right? These two are equal. They're the same triangle, okay? So now what we're asked to find is we are asked to find determine the length of side BD. So what is that? That's this one right here, okay? So now for me to find this length, I'm going to have to hopefully you figure out, I'm going to have to use these two triangles here, the green ones, to find out, first off, here, I'll change the color so that maybe that can, right, I'm going to use this triangle to find this side here, okay? And then once I know this side, I know this side is going to be the same because they're the same triangle. And then I want to figure out what this angle is going to be. Oops, I'll get rid of that. So I'm going to use some version of the cosine law once this is all said and done. All right. But it'll take us a few steps. So let's just get started and say, okay, so first step one, I want to find angle ACB. Okay, so that's this one, this, so like this angle, okay? Oh, sorry. I'm getting ahead of myself. Let's get rid of that. Okay, first off, I want to find the length of BC, okay? So Obviously, by now, hopefully you figure out that's going to be the cosine law. So it's going to be like BC squared equals 1.95 squared plus 2.4 squared minus 2 times 1.95 times 2.4 times cos of 45. Okay? And then again, this whole thing you can just punch into your calculator. So give yourself a second, try it out. I will do so on my end. So I got 2.94 approximately, and then square root that. So the length of BC is approximately 1.72. Let's just leave it at that, okay? So 1.72. So that's 1.72, and this is 1.72, okay? Because these triangles are the same. All right, everybody cool with that? And then next, what I want to do, well, how do I find this angle here? Well, I can't find it with this triangle, but in the green ones, right, what can I figure out? Well, I know I can figure out this angle, and then I know that is the same angle. So if I figure out this angle, then that one is going to be the same one, and then I can get the one in the middle that I'm looking for, okay? So step 2, okay, is I want to find angle ACB. All right. So angle ACB, if you look like from AC to B, I would just call angle C, right? But I didn't call it angle C because it's not just one triangle, right? But anyways, it'll be, if I use like sine of C over, right? This is side C. So 1.95 equals sine of 45 over 1.72. Okay, so then I cross multiply and have sine of C equals 1.95 times sine of 45 all over 1.72. And then now take out your calculator. So I have sine of 45 times 1.95 divided by 1.72. So I have sine of C equals, so this whole thing is 0.801661777400563. And then I do the sine inverse of this whole thing in there. And you should get second function sine. So I got approximately like 53 degrees. Okay. So remember, what did we just figure out? Well, we just said that this is 53, right? This one here. But then this one also has to be 53 because that's the same triangle. It's just on the other side. Okay. So now my third step, right? If I want to find, like, let's call it BCD. I want to find angle BCD. Well, that's just going to be 180 minus 53 minus 53, right? Because like the angle of a flat line is 180. So I go 180 minus 53 minus 53, and we get 74 degrees. So this chunk in here is 74 degrees, okay? So now I have side, angle, side. So to get side BD, I'm just going to use the cosine law. So this is my last step. So use cosine law to find BD, okay? Or sorry, did I write BC? I meant BD. Sorry about that. So BD squared is going to be, what are the side lengths again? They're the same, right? So 1.7, I'm sorry, 1.72 squared plus 1.72 squared minus 2 times 1.72 times 1.72. Oops, oh gosh. Let me just move that because I'm running out of space. Times cos of 74, right? So then now we take out our calculator, figure out what's on the right side. So I got 4.2859. So now I square root that. So the length of BD is approximately 2.07. Okay. And we are done. That's great. Wasn't that fun? So yeah, so here, like, there's definitely like multi-step solutions, and the questions obviously can revolve around SOHCAHTOA, they can revolve around sine law, or they can revolve around the cosine law, or a bit of both. All right. So hopefully those weren't too painful, and yeah, we will talk to you again soon regarding the next stuff. The next stuff, if I can give you a little prelude, is trig identities, which is it's probably the toughest part of the course. So it may be a little bit difficult for you to do that, given the fact that you're doing this alone. But again, check out the videos for trig identities, and you got to practice them. I know it's not a shocking tip that like you need to practice to be able to do the work, but these ones are going to be painful. And they're going to be painful if you don't practice. Okay. They're going to be painful if you do practice. So anyways, enough of me rambling. Thanks for listening, and we'll talk to you guys later. Bye.